In this section, we're going to be looking at midpoint and distance in the coordinate plane. So let's start off by looking at some key concepts, the midpoint formulas. First, we're going to look at the midpoint formula on a number line. The coordinate of the midpoint is the average or mean of the coordinates of the endpoints. So let's look at an example of this. Here we have a line that contains points A and B. The coordinate of the midpoint, which is M, is going to be A plus B divided by 2. So whatever value A is and whatever value B is would be added together and then divided by 2. And those red lines indicate that the distance from A to M and B to M are congruent. Now we're going to look at midpoint formula in the coordinate plane. The coordinates of the midpoint are the average of the x-coordinates and the average of the y-coordinates of the endpoints. So here we have a graph, and we have the segment AB with midpoint M. And we want to find the coordinates of point M. The coordinates of point A are x1, y1, and the coordinates of point B are x2, y2. So now, in order to find the coordinates of the midpoint, let's start with the x value first. We would do x1 plus x2 divided by 2. Then we would do y1 plus y2 divided by 2. And after we solve that, we would have the x and y coordinates of the midpoint. Now we're going to look at an example of this, finding the midpoint on a coordinate plane. Here we have the segment EF, which has the endpoint E of 7, 5, and point F at 2, negative 4. And we want to find the coordinates of its midpoint M. So again, we're going to start with the x-coordinate, and we want to do x1 plus x2 divided by 2. So here we would have x1, so we have 7 plus 2 divided by 2. And we can go ahead and simplify this to get 9 over 2, which equals 4.5. So the x-coordinate of the midpoint is 4.5. Now let's look at the y-coordinate. We want to do y1 plus y2 divided by 2. So that would be 5 plus negative 4 divided by 2. We can simplify this. We would get 1 over 2, which equals 0.5. So the coordinates of the midpoint of segment EF are 4.5, comma, 0.5. Now we're going to look at an example of finding an endpoint. The information we are given is that the midpoint of segment CD is negative 2, 1, and one endpoint, which is C, is negative 5, 7. We have to find out what are the coordinates of the other endpoint, D. So first we're going to draw a diagram of the information we have. So we can see that we've graphed point C, negative 5, 7, and we've graphed our midpoint, negative 2, 1. Now what we want to do is we want to find out the coordinates of the other endpoint. So we know what the midpoint is. So let's start with the x's. So we know that the midpoint equals x1 plus x2 divided by 2. So let's plug in the information we have. So we have the midpoint for x1, which would be, we have the midpoint for the x-coordinate, which is negative 2. So negative 2 equals negative 5 plus x2 divided by 2. Now we want to go ahead and solve for x in order to find out the x-coordinate of the other endpoint. So let's start by multiplying both sides by 2. This would give us negative 4 equals negative 5 plus x squared. X2. Then we can go ahead and add 5 to both sides. When we add 5 to both sides, we end up with 1 equals x2. x2 would be the x-coordinate of the other endpoint, D. Now we want to do the same thing for y. we have the y-coordinate of the midpoint, so we can go ahead and plug it in. 1 equals 7 plus y2 divided by 2. Again, we want to isolate the y2. So multiply both sides by 2. We get 2 equals 7 plus y2. Then you want to subtract 7 over. That would leave us with negative 5 equals y2. So now we know what x2 and y2 equal, and those are the coordinates of D, which is the endpoint. So the coordinates are 1, negative 5. Now we're going to look at another key concept when talking about coordinate planes, the distance formula. The distance between 2 points, point A, which is at coordinates x1, y1, and point B at x2, y2, is D equals, and in this case D equals distance, so D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we're going to go ahead and look at an example of this. We want to find out what the distance between point U, negative 7, 5, and point V, 4, negative 3 is. So let's go ahead and label our coordinates. We're going to make coordinates U, x1 and y1. We're going to make the V coordinates x2 and y2. Now we can go ahead and start substituting into the formula. So D equals the square root of parentheses x2, and in this case x2 is going to be 4, minus x1, which is negative 7, parentheses squared, plus parentheses y2, which in this case is going to be negative 3, minus y1, which is going to be 5, and parentheses squared. And now we can go ahead and start simplifying within the parentheses first. So we have D equals square root of 4 minus 7 would become 4 plus 7 because there's two negatives together, which leaves us with 11 squared, plus negative 3 minus 5 gives us negative 8 squared. Now we can go ahead and simplify further. We have the square root of 121 plus 64. And when we add them together, we get the square root of 185. And using a calculator, you can solve the square root of 185, and it comes out to be about 13.6. So the distance between U and V is 13.6.